Hello everyone, we are from class BEEQ1013, Introduction to Mathematical Economics. We from group 4 are going to present the answer for the past year question. So for the first question, find the total profit X function. The first step is to find the revenue function. Given the demand equation P equal to 10 over square root x, the revenue function is Rx equal to 10 square root x. And the second step is to find the cost function. The total cost to produce X unit given the average cost AC equal to 3 is cost function equal to 3x. So the last step is to build profit function. So after we get the revenue function and cost function, we substitute the revenue and cost function that we found, and the profit function that we get is 10 square root x minus 3x. The second question is what price will give the greatest profit. To find the greatest profit, the first step is to find the first derivative of profit function. So we must divide it as the profit function that we get from the first question. So we will get 10 over 2 square root x minus 3, and we simplify it and we will get the final answer of the derivative of the profit function is 5 over square root x minus 3. So for the second step is to set the derivative function equal to 0 to find the critical points. So for the first is 5 over square root x minus 3 equal to 0, and then we move 3 to the right and will become 5 over square root x equal to 3, and we move 5 to the right and it will become square root x equal to 5 over 3, and we move the square root to the right and it will become x equal to 5 over 3 to the power of 2, and x will become 25 over 9. So for the last step is to determine the corresponding price for P. So we get the we know that P is equal to 10 over square root x, and we will substitute the x from the answer that we get, that is 25 over 9. So P equal to 10 over square root of 25 over 9, and then we will get for the final answer is 6. Therefore, the price that will give the greater profit for the monopolies is Rm 6 ringgit per unit. This price corresponding to the quantity of X is equal to 25 over 9, where the profit is maximized.
Okay, so we want to prove that our profit is already at maximum using the second order condition. So in order for us to prove that, we have to derive again our function. So for our function is 5 over square root x minus 3, so we can change the square root x into x1 over 2. So we get 5 over x power 1 over 2, we minus with 3, and then we can bring up the x where we get 5x power negative 1 over 2 minus 3, and then we will derive this function where negative 1 over 2 we will multiply with 5, and then x negative 1 over 2 we will minus with 1. So from here we get negative 5 over 2 x powers negative 3 over 2. So our final answer would be negative 5 over 2x power 3 over 2. From here we could see that our final answer is negative, which proves that this profit is already at maximum level when our price is Rm 6 ringgit. The total cost function. So we know that the formula of total cost is fixed cost plus with variable cost. So from here it was stated that the manufacturing cost is 6,000, which will be our fixed cost. However, the variable cost, it was stated that it was Rm 5 ringgit. So we don't know how much is the total, so that's why we will have to multiply with the quantity, which will be 5x. So from here our cost function is 6,000 plus with 5x plus with x over 2 x power 2 over 60. That is the answer for our cost function.
Assalamualaikum and hi, my name is Muhammad Kim Khairul and my matrix number is 297259. So now we will move on to the next question, which is B2. The question is find how many units must be produced so that the average cost is minimum. So the given cost function for Cx is Cx equal to 5x plus 6,000 plus x the power of 2 divided by 60. So now the first thing first we need to do is we write the average cost formula, which is x equal to Cx over x. Then we substitute the given mathematical expression for Cx into the formula, resulting in Cx equal to x to the power of 2 divided by 60 plus 5x plus 6,000. And then we just divide the mathematical expression with x due to the average cost formula. Next, we find the first derivative of average cost function, which is Cx equal to 1 over 60 minus 6,000 over x to the power of 2. Then when Cx equal to 0, we write it as 1 over 60 minus 6,000 over x to the power of 2 equal to 0. Then we switch the place, making it into 1 over 60 equal to 6,000 over the x power of 2. Then we multiply it using the x formula. Then we just multiply it with each other, making it into x to the power of 2 equal to 360,000. So then x equal to 360,000, we define it into x equal to 600. So the unit that must be produced so that the average cost is minimum is 600. So moving on to the next question, which is B3. Within the interval 0 and positive infinity, find the interval where the average cost function is increasing or decreasing. So for the first one, when Cx greater than 0, we write it as 1 over 60 minus 6,000 over over x to the power of 2 greater than 0. Then we just change the place, making it into 1 over 60 greater than 6,000 over x to the power of 2. Then we will have x to the power of 2 greater than 360,000. Then we will have x greater than 600. Then we test another equation, which is when Cx smaller than 0. So 1 over 60 minus 6,000 over x to the power of 2 smaller than 0. Then we just change the place and we will have 1 over 60 smaller than 6,000 over x to the power of 2, and we have x to the power of 2 smaller than 360,000. Then we will have x smaller than 600. So the interval that where the average cost function is increasing or decreasing. So since x must be greater than 0, the average cost function is increasing for x in the interval 0, 600, and decreasing for x in the interval 600 infinite, positive infinity. So what we can conclude is for the interval 0 until 600, the average cost function is decreasing because it have a negative answer, while for the 600 until positive infinity, we will have a positive an increasing for the average cost function because it have a positive answer. So that's all from me. Thank you.
Hi, my name is Mustafa Muhammad Mustafa with matric number 297034. In this slide, we are asked to find the rate of increase in total cost. To do so, we start with the cost function Cx equal to 6,000 plus 5x plus x squared by 60. We then differentiate each term separately. The derivative of the constant term 6,000 is 0, the derivative of 5x is 5, and the derivative of x squared is 2x. Therefore, the rate of increase in total cost is 5 plus x by 30. This means that for each unit increase in x, the total cost increased by 5 plus x by 30. In this slide, we are asked to explain the derivative cx of the total cost function cx and its significance. The derivative cx represents the rate of change in total cost with respect to the number of units produced. From the previous answer, we found that cx is equal to 5 plus x by 30. Since the derivative is positive for x greater than 0, it means that the total cost increased as the number of units produced increased. The rate of increase in total cost per unit produced as found in the previous slide is 1 over 30 units. In summary, the total cost will continue to rise with an increase in production, and the rate of this increase is given by 5 plus x by 30.